Here we go with a second of our marine ecology presentations, this one on human impacts and how we've managed to mess up the ocean pretty good, but also how we've fixed it up a little bit as well. The first thing we spent a lot of time talking about is marine debris. Marine debris being any man-made material that is disposed of in the sea. Generally, we think of this as solid stuff. The most common examples that we've been talking about, of course, plastic bags and bottles, old fishing gear, ship garbage, things that people just kind of throw overboard without thinking. And then bigger things too, like sunken ships count as marine debris, or nowadays we hear a lot in the radio and in the news about tsunami debris making its way over from Japan. And all these things make their way into the ocean, whether they're put there purposely, like somebody just dumping trash, or accidentally, something just being littered on land and making its way in the ocean, or even just blowing out of the back of a garbage truck. And remember, if it finds its way to a river, it's probably going to find its way to an ocean. And why do we really care? You know, what's the big deal? Well, the problems of these things is, one, destroys habitat. So like if a large piece of debris were to fall on a piece of coral or something like that, or an old fishing net fall on a piece of coral, it might smother it, crush it, and that could be killing the coral underneath and destroying that section of habitat. Obviously, you can entangle animals, especially if it's things like fishing gear, or more famously those little six-pack rings where animals get those wrapped around their heads and they suffocate or just gets in their way. And then, of course, things are eaten by animals, like this sea turtle up here. They love to eat jellyfish, and plastic bags floating through the ocean often look like jellyfish. And so either, in case of this guy, he's probably going to starve to death because of that, or be suffocated. And something like this guy clearly ate a lot of plastic debris and always feels full, never feels hungry, and so eventually he'll die of starvation. But also, it's not just the giant things, too. You got little bits of plastic that are broken down bits of plastic, or just plastic pellets that just kind of float around in the ocean and look like plankton, so other fish and whatnot eat those guys, and bigger things eat the fish, and so on and so forth, and that can make its way up the food chain. And of course, even if plastic doesn't suffocate or starve the animals, all right, you could still be looking at plastic chemicals leaching into the tissue, which then you could ingest, and so that's not necessarily a good thing either. So lots of reasons why marine debris is bad. Also, another major concern are invasive species. There's two types of things you could think of: non-native species and invasive species. An invasive species is a species that's introduced to an area from another location, right? So they're not native to that area. To be considered invasive, right, you're a non-native species that's taking over because of an advantage, right? So you don't belong there, and not only do you not belong there, but you're kind of kicking everybody else's butt, right? Some of those advantages include maybe you don't have any natural predators, like if you're some kind of weed that nothing eats, or some kind of unique fish that nothing really recognizes. We saw that with the lionfish. When Lillian Tuttle came to talk to us, other predators don't recognize that as something that's good to eat. Another thing that's very common is these guys will reproduce a lot or very quickly, so that they quickly overwhelm everything else in the area with their babies. Or maybe they're a superior predator and they can just eat everything else and eat better than every other animal in that area. And the problem with this is it creates a monoculture. It takes out everything else, which harms the food web. We learned a lot about the food web, and you remove one or two organisms and other things are connected to them. Everything's all interconnected, so that can have a big effect on lots of other organisms. We also talked a little bit about succession. This actually isn't really a human impact, although it could be depending on what we're talking about. But succession is, in a general sense, the predictable pattern of change in an ecosystem following a disturbance. So disturbance could be natural, such as a volcano or hurricane, tsunami, something like that, but it could also be man-made. So like in this picture here, we've got this guy doing a little bit of destructive fishing, so tossing some dynamite in the water. We've got a shipwreck here, maybe it could be an oil spill, stuff like that. All these things disturb an ecosystem, right? So disturbance is something that changes an ecosystem, usually removes organisms. Not always, but usually removes organisms. And so following a disturbance, there can be a couple different types of succession. Primary succession is in an area, formation of a new community in an area with no previous life, or if life had been totally wiped out. So like a brand new volcanic island like we see up here, or a previous volcanic island where everything just kind of gets burned up by a volcanic eruption or something like that. So you're starting from bare rock. So that would be an example of primary succession. Or secondary succession would be succession area following a less drastic disturbance. So any of these guys over here that destroys stuff or ruins stuff a little bit, takes out part of the ecosystem, kills off some of the species, sort of resets it a little bit, but there's still something to go on. There's still some life there. There's still some primary producers there to keep the food chain going, things like that. That would be secondary succession. And then another major effect we have on the ocean is our impact on fisheries. Fishery would be considered anything the industries, organizations, or even the geographic area involved with the harvesting of organisms for food. So it's a pretty general definition of that. So like you could talk about like the Pacific Coast fishery could be all the entities that are involved in catching, for example, Dungeness crab or salmon, or think of like the crab fishery when you think of the show Deadliest Catch. So that would involve obviously the crab in that area, but then all those places that are also involved with catching it, the crabbers, the people on the boats, the canneries that accept the crab later on and process it, all that stuff is part of the fishery. And so the problem with the fishery is not necessarily a fishery, but when you overfish, right? When you do things a little bit too well, right? And how does overfishing harm the ecosystem? It harms the ecosystem because we have the ability to remove many fish at one time. With technology today and ships and fishing, we can remove vast numbers of fish, right? We could wipe out an entire school of tuna if we wanted to. And that's bad because obviously limiting reproduction, if you take away all the fish, there's no one left to reproduce, and we've learned before, we remove things that negatively affects the food web. All right. Of course, the good things that we do are putting limits on fisheries, monitoring, closing fisheries if it gets too close to dangerous levels, things like that. Again, going back to Deadliest Catch, if you ever watch that show, they always throw the females back because they know the females are producing the next generation. Things that you can do for overfishing. The main thing is making positive choices whenever you buy seafood. All right, eating lower on the food chain helps out. For example, down here you can see if you were to eat 1 pound of a top-level predator, right? Remember that 10% rule. He would need 10 pounds of fish to support him, and those 10 pounds would need 100 pounds of fish to support them, and those fish would need 1,000 pounds of plankton to support them. But if you eat a little bit lower on the food chain, these blue guys here, 1 pound of this guy, 1 pound, requires only 10 pounds as opposed to 100 pounds, and only 100 pounds of plankton. So it puts less of an impact on the ecosystem. Of course, you can also choose more sustainably harvested fish, so maybe non-destructive fishing methods. So are they catching all the fish out of a school of fish, or are they being more selective about it, catching it with hook and line? Or are they certainly not using destructive fishing methods? Like you wouldn't want to support somebody who's throwing sticks of dynamite in there, blowing up an entire reef. In ways you can help determine if something is a sustainable fishery is this Seafood Watch. Monterey Bay Aquarium puts that out. There's little paper guides you can print out and put in your wallet or pocketbook. There's also, of course, an app you can put on your cell phone. If you wanted to get that, here's a link to where you can find that seafood guide, little QR barcode if you wanted to scan that, and you could get the app. It'd be helpful for not so much you guys, but maybe your parents to help with some sustainable choices. And then related to this kind of whole thing, everything to do with the way we mess up the ocean, but especially with marine fisheries, is creating what are called marine protected areas. These are an area of the sea where fishing is prohibited or highly regulated. Think of it sort of like a national park out in the middle of the ocean. And so the good things, what's the good thing about having these parks in the middle of the ocean is it's going to protect the coral, which help protect the whole food web. Right? These guys are the primary producers. They also provide habitat if you're not allowed to fish there, and certainly not allowed to throw dynamite in the water. So protecting that is going to be good for the entire food web because remember, everything relies on those primary producers. It also provides an area where fish can breed safely so they can have their babies. You're not worried about killing pregnant fish, not that they get pregnant, spawning fish, things like that. And then, of course, the benefit is this going to improve fishing outside the area, outside the marine protected area. because the fish that live there certainly don't only stay within that marine protected area. They can leave the marine protected area, and then you're allowed to catch them. And so it improves the fishing on the outside there. So there we go, just a little bit of stuff on the ways in which we affect the ocean. I know your packet has some stuff on climate change. I sort of put that in there as an afterthought, and we may or may not have time to talk about that one, I don't know. But if we do, then we'll kind of do that as a traditional note-taking method. So nothing about that in this presentation.